This lesson is on inverse trigonometry, so we're going to work on finding missing angles in a right triangle rather than missing sides using the trig functions sine, cosine, and tangent. So looking at our original trig ratios, we know that we have sine of theta equals opposite over hypotenuse, cosine of theta equals adjacent over hypotenuse, and tangent of theta equals opposite over adjacent. And previously what we've been working on is using these trig ratios to find one of the missing sides. And what we're going to do is we're going to work on actually finding theta. And when we do that, we're going to use what we call an inverse or an arc sine function. So the sine of theta equals the opposite over the hypotenuse. And what I'm going to do is on each side of this, I'm going to do the inverse sine. And what that does over here on that left side is it cancels those sine functions out. So all we're left with on that side is theta, or the angle. And on the other side, we have the inverse sine or the arc sine over or times opposite over hypotenuse. And when we put that into the calculator, that will give us our theta or our angle. So it's important to remember that that theta sign represents the angle. And we'll do the same thing with each of the other trig functions. So I know that cosine of theta is adjacent over hypotenuse. So I'll be using the inverse of cosine. So then theta will equal the inverse cosine times the adjacent over the hypotenuse, and that will give me the angle. And again, we'll do the same thing with tangent. So tangent of theta equals opposite over adjacent. We'll use that inverse. And we'll be left with theta equals the inverse tangent of opposite over adjacent. Now in the calculator, if you're using a handheld calculator, you'll use the second button and then you'll hit the sine, cosine, or tangent button in order to get that inverse or that arc. And make sure that your calculator is in degree mode before you try to solve for anything with trig, because it will give you the incorrect answer if your calculator is in radian. Now we're going to do some example problems. So in this first one, I am working with this unknown angle. We're going to call that theta. And I'm going to look at the relationship between the sides that are marked and the angle. So this 14 is going to be the opposite side, and this 29, because it touches the angle and helps to create the angle, is an adjacent side. So when I have opposite adjacent, I've got SOH, CAH, TOA, or SOHCAHTOA. I know that I'm going to be using tangent. So the tangent of theta is going to equal 14 over 29. So when I'm trying to find theta, I know that it's going to be the inverse tangent of 14 over 29. And when I put that in my calculator, I get 25.7693. And let's say I wanted to round that to the nearest hundredth, that would be 25.77. In our next example, again, I'm working with theta. I've got an opposite side and then the hypotenuse. I know that's the hypotenuse because the right angle is pointing at it. And since I have opposite and hypotenuse, I know I'm going to be using sine. So the sine of theta equals 11 over 27. So when I use that inverse, I'm going to have theta equals the inverse sine of 11 over 27. And when I put that in my calculator, theta is going to equal 24.04207. If I round that to the nearest hundredth, it's going to be 24.04. And these are all degree measures because they're measuring that angle. So that angle is 24.04 degrees. In this last example here, I have theta, and I've got an adjacent side and a hypotenuse. So I'm going to be using the cosine of theta equals that adjacent over that hypotenuse. So when I'm just finding theta, or the angle, it's going to be the inverse cosine of 13 over 20. So theta is going to equal 49.4584. And if I round that to the nearest hundredth, it's 49.46 degrees. So this isn't really any more difficult than regular trig ratios when we're finding sides. You just have to remember to use that inverse button or hit second before you hit the trig function button. Now here are some practice problems for you to try on your own, and we will go over each of them. So our first practice problem, we have our theta, and we have an opposite, and we have an adjacent, so that's going to be tangent. So tangent theta equals 27 over 38. So the inverse of 27 over 38 is going to equal theta. So then that angle theta is going to equal 35.39 degrees. In our second example, we have an opposite and a hypotenuse, so that's going to be sine equals 10 over 39. So then theta will equal the inverse sine of 10 over 39. So then theta equals approximately 14.86 degrees. And again, that's rounded to the nearest hundredth, so that's not exact, so it's approximately that many degrees. And in our last one, we have theta, and we have an adjacent and a hypotenuse. So we'll be using the cosine of theta. That's 4 over 5. So then theta will equal the inverse cosine of 4 over 5. So theta is approximately 36.87 degrees.